Hey guys, George at SoundTraxx here. This week we're going to jump back into a series we had done in the past. We haven't done a video for it in a while, called Back to Basics. This is where we're going to take various basic beginner aspects of the decoder and maybe a refresher for some of you veterans out there to just kind of look at some of the settings and adjustments you can make with the decoders so that way you can get your railroad running the way you want it. So let's get back to basics. Now, in the past series of our Back to Basics, you can take a look at the playlist down below. But we've talked about various topics such as what is a CV, how is the CV structured, and so forth. Well, today we're going to dive into one of the more important CVs just to kind of give you a little bit of a background. This is CV number 29. Now, CV 29 governs 5 major aspects of how the decoder operates on the track. And we're going to talk about each one of them and what they mean today. Today we're going to talk about in CV 29, we're going to start with one of the more important aspects of setting the CV value. And this has to do with the address type. Now, if you're familiar with DCC, and we may have touched this in the past, and if not, go back and look at the videos, but we talk about the address type. You have what's known as the basic address or the simple address, which is a number between 1 and 127. And then you have what's known as the extended address, or what's commonly known as a 4-digit address, or a long address, or depending on what type of lingo you're using. Now, this address can actually be a number between 0001 all the way up to 9,999. It actually goes a little bit higher than that, but most DCC systems don't talk to it, so we'll just leave it within the 4 digits that you might find on the cab of your locomotive. But the type of address is actually important because it tells the decoder which address command to respond to. Now, when it comes to the short address, that's stored in CV1. And as I mentioned, a number between 1 and 127. Now, the long address or the 4-digit address is actually stored in CV17 and 18 through I'll say somewhat unnecessarily complicated mathematical algorithm that you have to do to determine CV17, which is the quotient, and CV18, which is the remainder values. So the good news is most DCC systems do the work for you. But in CV29, you want to pay attention because this is what determines which address type is active. So many times when you're setting the address using your DCC system, it will actually set the bit in CV29 to turn on the long address or the 4-digit address for you. Some systems will let you set it and then ask you quickly, activate this address. You type yes, and then it goes and sets CV29 so that address is now active. One little thing to note on addresses is when your decoder is on the main line, and let's say, for example, this locomotive that's sitting here in front of me, 3223, if I try to change the address of 3223 to, say, 3224, for whatever reason, the decoder will lock that out because it knows the long address, or 4-digit address in this case, is actually active and you're on the main line, so it doesn't want you to accidentally lose control. Let's say, for example, you were trying to program 177 and accidentally program CV17. So that's a safeguard to help you protect from losing control of your decoder. For more on addresses, be sure to check out our manuals on our website as well as other videos we've done in the past. Now, the next aspect of CV29 we're going to talk about is what's called the normal direction of travel. In other words, which way is forward. Now, on many diesel locomotives is where you'll primarily see this, where you'll see an F located here on the front sill of the locomotive. And that's what designates front. So when engineers or crew see that it's forward and they hear that 2 honks to blast to go forward, they know that locomotive is about to move this way. But there were other railroads, such as the Norfolk Southern, even going into the other railroads, the Southern Railway and early hood units. A lot of times they had long hood forward, even in the early days of the GP7s, GP9s, those type of things. So this allows you to wire your locomotive in conventionally, where the short hood would be forward. But then if your railroad has the long hood forward, then you can enable that, and then every time you go forward, the long hood will be forward. Now, if you're installing the decoder, you can certainly go in and wire it up in such a way that that is forward, so you don't need to change it. But again, that's up to you as the installer. Speaking of installers, the other thing CV29 can do is, let's say you get all the way done your installation and you realized, oh crap, my headlight works, my backup light works, but the motor's wired in backwards. Now I got to take the thing apart again. Well, the good news is you don't necessarily have to do that. You can use this part of CV29 to reverse the direction of travel. So now when you're moving in forward, the throttle actually shows forward because that'll compensate for the motor being wired backwards. The only caveat here is it also flips and reverses your direction of travel for your lights. So if you want to have directional lights, you'll need to use CV57 and 58 to swap the direction of the lights so that way your decoder will have the headlight on when you're moving in forward. Ideally, go in and fix it so that way if you reset the decoder for whatever reason, you don't have to remember that, oh yeah, I have to do that and everything. But you do have it there as a safeguard. Now, the next aspect of CV29 has to do with the number of speed steps. Back in the early days of DCC, we had 14 speed steps, where it took 0 to 100%, divided it up by 14. As you can imagine, those increments to get to 100% were much larger. Well, as the DCC progressed, we got to 28, and then now we're actually at 128 speed step mode. So obviously I encourage y'all to be using 128 mode because that's the slowest, the smallest increments of change. So that way when you go speed step 1 of 128, you're actually going a whole lot slower than step 1 of 28, which is about speed step 5 of 128 step mode. Anyway, sorry, I didn't mean to get sidetracked there. But the CV29 tells the decoder whether it's going to be in 14 speed step mode or in 128 speed step mode. Now, this has less to do with the actual command coming from the decoder, telling the decoder how fast to go, but it has more to do with the location in the DCC packet for the headlight. So that, let's say, for example, if you're running in 14 speed step mode on the decoder, but your system is transmitting 128 mode, the ones and zeros may have the headlight command here, but the decoder's expecting the ones and zeros to be here. And so what can happen then is you can get an erratically behaving headlight because the ones and zeros aren't decoding the message properly. And so you always want to make sure that your decoder's matched to the method that you're using from your DCC system. Now, a lot of the more modern DCC systems don't even do 14 speed step mode, but if you have one that does, go ahead and try to use the 128 mode. Our decoders come with 128 mode enabled by default, so that way you can match most modern day DCC systems. Now, the next one has to do with analog. Now, this is if you're going to use your decoder on a power pack, whether you're using variable voltage power pack or a DCC system or both. So in CV29, our decoders are shipped with analog mode disabled because way back when in the early days of DCC, some systems would send out a pulse of 12 to 14 volts on the rails to test for short circuits so that way before it turns on the digital system, it would then detect that, oh no, there's a short circuit, we need to shut down. The problem is if analog mode is enabled, when that 14 volt pulse of power comes in for a few seconds, your motor starts running down the track because it's analog and it's told to respond. So we leave that disabled, and I highly encourage you to leave that disabled unless you plan to use a variable voltage power pack to run your trains. In which case, if you have that and you do want to run it, you will need access to a DCC system to set CV29 to enable analog mode. Now, the last part is what's known as alternate speed steps. And by default, the decoder uses a straight linear table that as you move up through the speed range, the increment changes and you basically get a linear table. But if you're going to create a custom speed table, like say, for example, you're going to go through and set CV 67 through 94 to create its own table to make sure to speed match perfectly throughout the range, then you're going to want to enable that in CV29. If you're using a straight linear table or you want to use CV's 5 and 6 to create a speed table, then you would leave alternate speed tables disabled. So CV5 and 6 are enabled at that point, but once you go to the alternate speed table, 5 and 6, you can set it, but they're not being referenced because the decoder at that point is going to reference the more detailed speed step commands from 66 through 95. So that way you can get the fully custom speed table that you're looking for. Now, all of this can be found in our user's guide. If you go to the manuals, the user's guide, you can see a page similar to this where you see it on the screen. And that's the breakdown of the CV bits to show you which bit is valued for which aspect of the decoder's performance that you're going to govern. Now, if you flip to the second page of the user's guide, when we talk about CV29, you can see this full-paged chart that answers the questions from left to right. And as you work your way across the screen, for example, address type. If I'm using a long address, then you look at that first column. At that point, the whole top half of that chart is no longer in play. So work your way across as you answer the questions, this or that, yes or no. And when you get to the final column, you'll see a value. So most decoders out of the box, if we set the address to a long address, you can see that we have the long extended 4-digit address. We're not going to use custom speed tables. We are not going to enable analog mode. We're in 128 speed step mode, and we have the normal direction of travel. You can see that that value would be 34 set in CV29. So it's always a good idea to understand where your decoder is going to operate before you set CV29 manually, because most cases, if you just change the address and you're perfectly happy with the speed tables, the DCC system will do the work for you. Now, of course, it wouldn't be a George video if I didn't plug our Blue NAMI. So if all this CV stuff kind of gives you a headache and looking and calculating it all, maybe you take a look at Blue NAMI, because as you go through the menus in the Blue NAMI app to set up your decoder, you can just click this or that, check this or that, and the app will set CV29 for you so that you get the proper way that you want to run your decoder. Then, if you want to run it with your DCC system, great. You can run it with DCC, or you continue running it with the app. It's entirely up to you. Now, that's everything I've got planned for you guys. I hope this was helpful for you. If you have any questions, feel free to email us at support@soundtraxx.com or give us a call. We answer our phones Monday through Friday, 9 to 5:30 Mountain Time, except for between 3 and 4 p.m. on Tuesdays, because that's when we're in an all-staff meeting. So if you get us during that time, just leave a message and we'll get right back to you. Anyway, thanks for watching, guys. Be sure to like this video, subscribe to our channel if you want to see more of this type of content. We're trying to do our best to help you understand how all the digital stuff works so that you can enjoy your hobby just a little bit more. Thanks for watching. We'll see you next time.